Hello and welcome to the demonstration of our tool, the Deployment Model Abstraction Framework, or in short, DeMAF. My name is Marcel and I am a PhD student at the Institute of Software Engineering at University of Stuttgart in Germany. The DeMAF allows to transform deployment models created with various deployment technologies like Kubernetes or Terraform into one deployment model that it can express the application deployment independent of such deployment technologies, called the technology-agnostic deployment model. That way, we aim to improve the comprehensibility of deployment models and allow people to understand them even when they do not have experience in the used deployment technologies. We would like to demonstrate the tool with the help of a deployment model that deploys an application called the T2 project, which is based on a microservice reference architecture. It comprises several microservices and databases that provide an e-commerce webshop for selling and buying tea. It uses 4 deployment technologies to deploy the application on a Kubernetes cluster that you can see on the bottom. The bash script on the left executes all other deployment models to provide full automation of the deployment process. It executes a Terraform deployment model for deploying the Kubernetes cluster. Then it deploys all the software components of the application on this Kubernetes cluster. For some services, we provide Kubernetes configuration files, and for others, we use Helm charts, as you can see with the annotations in the T2 project application. If somebody wants to understand this deployment model based on the provided models, they would have to understand all the used deployment technologies, the technical details, the modeling languages, and also the overall orchestration. As a result, a clear picture and overview of the entire application with all the services, databases, and the dependencies in between are very hard to get from this technology-specific deployment model. And therefore, we present here this Deployment Model Abstraction Framework. The DeMAF follows a plugin-based approach to provide support for the transformation of arbitrary deployment technologies. And each plugin is an independent microservice. Currently, we have 4 plugins registered for the transformation of the 4 deployment technologies that are used in the deployment model of the T2 project. The plugins register at startup at the Analysis Manager, which manages the transformation process by distributing tasks for the transformation of the individual nested deployment models. It does that by communicating with the plugins through a message broker. Additionally, the Analysis Manager offers a command line interface to the user, and you can see it here now. It's called the DeMAF shell, and it provides mainly 2 commands. The first is the plugins command, with which we can simply list all the registered plugins that are currently supported by the framework. And then, of course, also a command called transform. And the transform command, we have to supply 3 different parameters. First of all, we have to supply the location of the deployment model, which can be a URL to files on the local file system, but possibly also from a remote source. Because the bash script is here the starting point, we point to this file. Additionally, we enter bash as the deployment technology that is used for this file. Lastly, we also supply the command used for executing this model. In this example, this is not that interesting, but in other cases, one may supply important information like parameter values in addition to this command, and the DeMAF needs to know this to get all the information from the deployment model. By executing this command now, the transformation process starts. It sends a first task to the bash plugin to analyze the script. And the bash plugin then recognizes the embedded Terraform, Helm, and Kubernetes deployment models, and consequently, the system creates new tasks and distributes them to the corresponding plugins. In the end, the DeMAF notifies a successful transformation of the deployment model. We can now access the created technology-agnostic deployment model from this given file location. And you can see it now here. I open it in Visual Studio Code. And it is a YAML file, and it is based on the Essential Deployment Metamodel, in short EDMM. EDMM models contain no deployment technology-specific details and only describe the components that get deployed, their configurations, as well as their dependencies to other components. EDMM models provide all information required for understanding the architecture of the deployed application and require no technical expertise about concrete deployment technologies. As you can see, there are now different components that represent the T2 project components. And this includes infrastructure components as well as software components. Like, for example, we have here the physical node, but also here down there, we have the MongoDB for the card repository. And then additionally, we can also view the relations between these components that are listed here. And this is fairly simple to understand. And with the relations, we can also see the dependencies between the individual services. I hope we gave you a nice overview about the DeMAF system that we developed. And thank you for listening.